Okay, so we're going to begin day 2 of graphing parabolas. Day 2 of graphing parabolas. So let's begin by reviewing a tiny bit from yesterday. From yesterday, we learned that a parent graph is the easiest type of graph, in this case y equals x squared. It produces this beautiful parabola. It's a regular U-shaped curve. And we graphed it yesterday using an XY table, and we recognized the a value of 1 produces this exact parabola. The a value of 1, remember the a value tells you if the parabola is wider or narrower. But if your a value is 1, it's going to end up producing these coordinates, and we use these coordinates from the parent graph to use as a pattern to graph any parabola that has the a value of 1. You guys remember that from yesterday, right? Okay, so any parabola, and as a matter of fact, all the parabolas that you did yesterday, all of them had the a value of 1 or negative 1, so they were all equally this wide. None of them were wider, none of them were narrower. The a value was 1, so they're all equally this wide. And again, to get this perfect width of a parabola, we're going to use the pattern 1, 1, 2, 4, 3, 9. And we use it whenever the a value is 1. That's what we did yesterday for the homework. Now, as you can see, this is like our second part of graphing parabolas. So right here it says, if your a value is not 1, then you can, and I give you some options here, some steps on how to graph with the function. Let's do this right now. Cross that out. Okay, we're going to cross it out because I decided let's just get right to it. I don't want you guys to waste time and do all this math when you already know the pattern, 1, 1, 2, 4, 3, 9, and you could simply modify the pattern, okay? So let's first identify what the vertex would be on this one. Let's graph this the way we know how. What's the vertex? -4, you think opposite on h, and you take k for what it is. So -4, comma, -6, that's your vertex, correct? Let's actually graph that vertex, -4, -6. So let's go -4 on the x, 1, 2, 3, 4, and -6 on the y, that's way down here. Now, the next thing to do, based off of yesterday's notes and yesterday's problems, after you graph that vertex, you draw that vertical line, that dotted line. What do we call that dotted line? Anybody? Axis of symmetry, right? And just for funsies, let's write down A of S. It's going to be the axis of symmetry equation. And it's really easy to write the axis of symmetry equation. It's going to be x equals the x value of your vertex. The x value of your vertex is -4. So the equation x equals -4 will produce that vertical line that crosses the x-axis at -4. That'll cross right through the vertex. Any questions so far? So far we haven't done anything new. Now, yesterday, this next part would be to use the pattern to create coordinates, right? And the pattern was 1, 1, 2, 4, 3, 9. Now, the problem is this, guys. This pattern is from what? It's from the parent graph, the a value of what? 1. A value of 1. And this a value, is it 1? No, it's not. So we know that if this changes, this will cause it to become more narrow, right? This becomes more narrow, the parabola. So we can't use this pattern. Well, not yet. See, what we have to do is recognize that if you put a number out here in the front, how's it going to affect your output? Well, you're going to have to multiply it by 2. So what we need to do here is go to the outputs of our pattern. And on the pattern, we have these are the inputs, these are the outputs. Let's go to the outputs of our pattern, which are these guys right here. And let's multiply them. Let's modify them by multiplying by that new a value. And the a value happens to be 2. So let's go to that output of 1 and let's multiply it by 2. Let's go to the output of 4, multiply it by 2. The output of 9, multiply it by 2. Thus producing a new modified pattern. Instead of 1, 1, it's going to be 1, 2. Instead of 2, 4, it's going to be 2, 8. Instead of 3, 9, it's going to be 3, 18. And we're not even going to use 3, 18 because this graph is way too small to move 18 spaces, right? But once again, your old pattern that comes from the parent graph, a value of 1, the 1, 1, 2, 4, 3, 9, we modify the outputs of that by multiplying the outputs by your new a value. So instead of 1, 1, it's 1, 2. Instead of 2, 4, it's 2, 8. Instead of 3, 9, it's 3, 18. Does everybody understand that? Okay, so now we could go back to the vertex. Now we already know that the a value tells you if it opens up or down. Does this open up or down? up because it's positive. So normally, if it were a value of 1, I'd go 1 over and 1 up, but it's not 1 over and 1 up. What is it? It's 1 over and 2 up, which clearly 1 over and 2 up is going to be more narrow. And we already knew it was going to be more narrow because the a value is further away from 0. So let's put a dot right here. 1 over, 2 up. Let's all put a dot right there right now. And then we're going to go back to the vertex, and we're going to go 2 over 8 up. So if you go 1, 2, 8 up, 1, 2, 3, 4, 5, 6, 7, 8, put a dot right there. And if I went back to the vertex, I went 3 over 18 up, I'm going to be way off the graph, so I'm not even using that last one. Everybody with me? And like always, whenever you get those coordinates, mirror them over the other side of the axis of symmetry. It's going to be right there. It's going to be over here. And guess what? We're done. Let's just graph this parabola right here. Oh man, that was crooked. Hopefully you do a better job than me. I'm sorry. Put some arrows. And yeah, that's slightly more narrow than your parent graph. Why is it more narrow? Because the a value is 2, which causes a vertical stretch, which means that it gets narrower than the original parent graph. There's a couple other things we could state, like the domain, x equals all real numbers, because any parabola is going to go to the left and to the right forever, right? It doesn't matter if it's wide or narrow, opening up or opening down. The domain will always be x equals all real numbers. The range is going to be it's either going to be greater than or equal to or less than or equal to, depending on if it opens up or down. So what do you guys say? Greater than or equal to. And technically it's going to be the y value of your vertex, -6. Because the vertex, after all, is the lowest point. It's either the maximum or the minimum point. So you could just say y is greater than or equal to the y value of your vertex. We've stated everything that we can about this parabola without doing much math. The only math that we did was multiplying your outputs of your original pattern that we learned yesterday by 2. So I think this is the quickest, most effective way of doing this. I mean, what other possibilities are there? You could have said, oh, I'm going to graph this making an XY table. Give me any number to plug in, just so you could see the amount of work. You want to plug in, let's plug in something that's closer to the origin. 3. Okay, so if you were to plug in 3, think about this. If you were to plug in 3 right here, 3 plus 4 is 7. 7 squared is 49. 49 times 2 is 50, no, 100, no, 90. Man, I can't even think right now. 98, and then minus 6, 92. So for the input 3, you'd get the output 92. That is a coordinate, but that means that 3, 92 is going to be way off the graph. So doing an input-output table, not only is it easy to make mistakes when you're calculating math, as you saw me struggle through that, sometimes you get coordinates that are way off the graph. So I decided to forget input-output tables. Let's just stick with what we know, that the a value of 1 produces the pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. And if your a is different than 1, all you have to do is modify your outputs according to that new a value. Does that make sense? It's really simple. If the a value happens to be 3, what are you going to multiply all your outputs by? By 3. If your a value happens to be 1/2, what are you going to multiply all your outputs by? By 1/2. So whatever your new a value is, simply multiply your outputs by that new a value, and that will change the parabola accordingly. So that's what I explained down here. Again, I did not go with my original options of using a XY table, so you could scratch that top part out and just focus in on this. Right here it says you can modify the pattern according to your new a. If your a is 2, you can modify the outputs of your pattern by 2. So here's your original input-output pattern. So again, I'm going to explain multiply the output by 2, multiply the output by 2, multiply the output by 2. It's kind of like taking your outputs and multiplying by your a value, right? Which happens to be 2 in this case. So again, 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. So your new modified pattern for the a value of 2, here's your new modified pattern for the a value of 2. It's not 1, 1, it's not 1, 1 anymore. It's 1, 2. Here it is, 1, 2. It's not 2, 4 anymore. It's 2, 8. It's not 3, 9 anymore. It's 3, 18. So am I saying memorize this? Heck no. Don't memorize this, because I don't want you to memorize a bunch of different patterns. Just know that one original pattern, 1, 1, 2, 4, 3, 9, that comes from the a value of 1, and you could modify that pattern to any pattern you want based on your new a value. So let's see if that makes sense to you guys. Let's go to this one down here. Let's begin the way we always would. What's the first step on graphing a parabola? You got to state the what? The vertex. Everybody put a V right there. What would the vertex be according to H and K? Thank you. -1 and 1. We got it. Okay, so let's go to the coordinate -1 and 1, and let's put a dot right there. So it should become like a reflex for you. All right? Like once you graph that vertex, what do we draw right through it? The axis of symmetry. Okay? If you don't think that, that means you haven't done it enough, right? Whenever you graph your vertex, draw the vertical line, the axis of symmetry. Yeah, you have to. Because trust me, it makes it easier for you. It makes it a lot nicer when you reflect the coordinates over.
Like if we do it on a test or we don't do it after?
Well, see, on the test, I might specifically ask you for what is the axis of symmetry equation. And the axis of symmetry equation will be, you have to write x equals and the x value of your vertex, the h value, which happens to be -1. I mean, and that makes total sense, right? Because if I say the equation x equals any number, you go to your x-axis, you go to that number, and you draw a vertical line right through it. X equals -1 is the vertical line that goes right through the x value of your vertex. Make sense? Okay, so why do I want this axis of symmetry? So when I come up with my pattern, it becomes really easy to map it over to the other side. So what pattern do we know? We know 1, 1, 2, 4, 3, 9. We know that. Everybody jot that down. That's our original pattern. And the original pattern had the inputs of 1, 2, 3, had the outputs of 1, 4, 9, right? So we need to change the outputs. We need to change the outputs by doing what? Multiplying by this new A value of 1/4. So go ahead and multiply by 1/4, multiply by 1/4, multiply by 1/4, and some of us are going to get weirded out right here because of the fraction, but you shouldn't, right? Because if we say, what is 1 times 1/4? That's just 1/4, right? No big deal. So let's write down 1/4, or if you don't like fractions, you could say, convert it to a decimal, 0.25. So it's 1/4 of the way to the next unit. How about 4 times 1/4? What's that? That's 1. Nice, beautiful 1. That one's easy. How about 9 times 1/4? 2 and 1/4, right? You could say, put 9 over 1. 9 times 1 is 9. 1 times 4 is 4. 9/4. 9 divided by 4 will go in 2 times with the remainder of 1 over the original 4. Or you could say with the calculator 2.25. Calculator does it all for you. Don't freak out. So anyways, what's our new pattern? The new pattern is 1, 0.25, or 1 and 1/4. 2, 1, 3, 2.25. Okay? So let's see how that looks like visually. Again, this is a pattern. These are not coordinates. This is a pattern from the vertex. So from your vertex, you're going to go 1 to the left and 0.25 of a unit up. Why up? Because the A value is positive. So check this out. From the vertex, 1 to the left or right, doesn't matter, and 0.25 of the way up. That's not even halfway. That's only halfway to the halfway. Does that make sense? So 1 over 1/4 of the way up. Everybody put a dot right here at 1/4 or at 0.25 of the way up. Let's do that. Again, it's not quite halfway. It's half of the half. And now let's go back to the vertex and go 2 over 1 up. That one's easy. 2 over 1 up. Let's put a dot right here. Hopefully everybody's following along. Let's go back to the vertex and let's go for the last one. 3 and 2.25. Or 3 and 2 and 1/4, whatever you want. So 3 to the right, 1, 2, 3, and now 2 and a little bit more, 2.25. 1, 2, and a little bit more. Not quite halfway, but it's half of the half. Are you with me? So this is probably one of the hardest ones that there is, and I hope we all understand it. All we need to do now is mirror it over to the other side of the axis of symmetry. So this guy that was 0.25 of the way between 1 and 2, it's 1 unit away from the axis of symmetry, so go 1 unit this way, but it has to still be 1/4 of the way between 1 and 2, so it's right here. So 1 unit away at the same exact height, that'll be right there, half of the half right there. And then let's go to this other one. This one's 2 units away, so go 1, 2 units away, and put that dot right there. The last one is going to be up here, which is clearly 1, 2, 3 units away, 1, 2, 3 units away at that same y level of 3 1/4 of the way up. Does that make sense? Okay, so now let's just put a line through it. We have our parabola. And if you're thinking, well, that parabola is a lot wider than usual. Heck yeah, it's wider than usual. Why is that? Because the A value is closer to 0. right? The regular A value of 1 gave us the original 1, 1, 2, 4, 3, 9, but this is a lot closer to 0. That's why it got vertically compressed. It's definitely wider, okay? So I hope we understand that. Let's, what else could we say about this? Well, what's the domain?
X is equal to all.
X equals all real numbers. How about the range?
Y is
Greater than or equal to 1, that's right. And that's all I'll be asking you for on the test Friday with regards to these types of questions. Let's look at another one up here, guys. So, ladies and gentlemen, the first thing to graph a parabola is what? What do I identify first? The vertex. Everybody put V and state the coordinate of the vertex according to H and K, but make sure you think opposite on H. So what's a vertex? Thank you. Let's go to -3, 6, -1, -2, -3, and 6 is way up here. And almost like a reaction, once you graph the vertex, what do you draw right through it? There you go, axis of symmetry, that dotted line. This will provide you a reflection. It'll help you stay organized and make sure you graph it correctly. Okay, so please do that. If I were to ask you for the axis of symmetry equation, what would that equation be? You have to say x equals h, which is the x value of your vertex, which is -3. See, it's really easy, right? Now, we need more coordinates. Now, normally if your a value is -1, you just go 1 over 1 down. You go back, you go 2 over 4 down, 3 over 9 down. But we know that the a value is not 1. The a value is 2. Well, technically -2, but I don't care about the negative. That's just telling me that it's opening down. So I am going to write my pattern that I know for the a value of 1, which is 1, 1, 2, 4, 3, 9. And what am I going to do to the outputs? I'm going to modify them by doing what? Multiplying by this new a value right here, by the new a value of 2. So some students say, well, why don't you multiply by -2? I don't care about the negative sign. The only thing I care about the negative sign is that it's going to open down, and I already know that. So I'm just going to multiply the outputs by 2. I mean, not by 2, I'm sorry. Yeah, by 2. Okay, so instead of 1, 1, we're going to get 1, 2. Instead of 2, 4, we're going to get 2, 8. And instead of 3, 9, we're going to get 3, 18, which obviously we're not even going to use that part on this small, tiny graph. All right, so let's go to the vertex. I'm going to go 1 over and 2 down. Why am I going down? Because it's negative. See, that's where it matters, if it's going up or down. So 1 over 2 down. Put a dot right there, please. Whoops, let me do that in red. Let's go back to the vertex, and this time we're going to go over 2 over 8 down. So go 2 over 1, 2, 8 down. There's 6, 7, 8 would be right there. Please count carefully. And after that, if you go back to the vertex and go 3 over 18 down, you're going to be way off the graph, so I'm not even going to worry about that. So let's just map those coordinates over to the other side. That's 1 right here. That's 1 down here. Go ahead and draw your line through that parabola, through those coordinates. And we are done. What's the domain for that one? Again, the domain of any parabola, doesn't matter if it's wide, narrow, up, opening down. The domain of any parabola is x equals all real numbers. How about the range? Y is less than or equal to the y value of your vertex, which happens to be 6. Because remember, the vertex is your maximum height. And what is that height? That's the y value of 6. So it's either at 6 or below, which is less than or equal to 6. What do you guys think? It's not bad, but it does require practice, right? You have to practice. Let's go for one more, and then I'll let you work on it on your own. What would the vertex for number 2 be right here? 0 for h, because there is no parentheses, right? There's no number being added or subtracted inside the parentheses with x. But the k value is the number that's being added or subtracted at the very end. So 0, 4 is the vertex. Go to 0, 4, put a dot right there. Normally, we draw an axis of symmetry right through it, even though it's very clear it's the y-axis in this case. Now, we need coordinates. We need a pattern. What pattern do we know? 1, 1, 2, 4, 3, 9. How am I going to modify the outputs of this pattern? By multiplying by what? By multiplying by the a value of 1/2. Don't worry about the negative. That just tells you that it's opening down. So multiply it by 1/2, multiply it by 1/2, multiply it by 1/2, And let's actually write down the outputs here. 1 times 1/2 is 1/2, which is 0.5 if you want. 4 times 1/2 is what? 2. How about 9 times 1/2? What's half of $9? $4.50. 4.5. Are you with me? So the pattern, the new modified pattern, according to this new A value of 1/2, is 1 1/2, 2 2, 3 4.5. So let's go to the vertex and let's use that pattern. 1 over and then only halfway down. So be specific, be intentional, try to go perfectly halfway in between, right there. Everybody please put that dot. 1 over, halfway down. Okay, then we go back to the vertex and we're going to go 2 over, 2 down. That one's easy. 2 over, 2 down, put a dot right there. And then we go back to the vertex and go 3 over and 4.5 down. So check this out. 1, 2, 3, 1, 2, 3, 4.5, halfway. So right here. Let's put the right there halfway down. And now we're just going to Yep, losing my mind. Now we're just going to map it over to the other side, okay? So this one at the halfway point is 1 unit away, go 1 unit away this way. The other one's 2 units away, there it is. The other one's 3 units away at the halfway point, there it is. Draw your parabola and you're done. There it is. So what's the domain right here? Yes, what's the range? That's right. Okay. So I believe that we have enough knowledge now to do the rest of these 3, 4, 5, 6, and 7, right? Because all you're doing is taking your original pattern of the A value being 1 and then modifying it according to your new A value, modifying the outputs according to your new A value. So I'm going to stop right here. Please work on the rest right now. The answers are on the back, so you could check yourself if you're going in the right direction or wrong.